Hi everyone, welcome to Math Monday. So this is your first online lesson, and it's going to be a pretty quick one because this is covering a topic that we've already done in class already. If you could open up your math books to page 250 here, it's lesson 7.7 in your book. We're going to go through lesson or page 250 together, and then you're going to reverse it and do page 49 on your own. Okay? As you can see in the slideshow and the Google slideshow, we've talked about what line plots are already, but we know that a line plot it's a graph or a type of visual representation of a collection of data. So here we have that my cut up strips of color paper to make a collage. The lengths of the unused pieces are shown in the table. So she's gathering information about what she did not use. Remember, we always like to try to have a visual representation in our head of what our data means because it's going to make more sense to us that way. So in this case here, we have, she measured each piece of her unused pieces in inches. Remember, this is inches, so that's important for us to know. So as I can tell here, I have 4 half-inch pieces left, 2 5/8 of a piece, 2 3/4, 2 7/8 of a piece, and 2 pieces that were 1 1/4 inch long. And this is great to have, but sometimes it's much better to have it in some kind of picture so that when we glance at data, we can make good assumptions and better and quick decisions about what we have. So remember a couple things in a line plot. You have to have a title. So here's our title, paper lengths, and you have to have something that defines your measurement. So here it tells us that it's in inches, so that way in each one of these we don't have to write the abbreviation for inches. We know that that's what this is. A couple things I want to know. Do you notice this part here? It's like a break in your line. So you have a line and then you have a little break or a little spot. What that means here is if you look here, we have 0 all the way to 1 1/4 or 1 1/4. This means that this tiny little line here is really not representing all the fractions from 0 to 1/2. If that's the case, then 0 really should be around here rather than over here. So this break in line tells us, it is a different way of telling us that this section of our line here is actually supposed to be longer. So I want you to understand that that's not a point on our line plot. It just tells us that this particular line here or this space should be longer. So what we're going to do is go ahead and plot our line here. So if I look here, I have 4 pieces that are 1/2 inch. So I'm going to look for my 1/2 inch, and I remember this is the time that we pick a usable symbol, not something that's really detailed. So I like to use X's because they're easy to make and they're clear to see. So I have 4 of them. So I'm going to put 4 here right on top of one another. And it's going to bring me all the way to the top. Notice that I tried to keep them as close as I could or in an orderly fashion. I'm not going to crunch them because it's going to be hard for me to see my data. So when I'm doing this, when I look at my 5/8 here, it tells me I have 2 pieces. I'm definitely not going to do this. Now I want you to pause and tell someone at home why you wouldn't do that. Okay, you're paused. All right, why would I do that? Because here is what it really looks like. This is the length of what 2 of my plots should look like, so it should look the same here. Otherwise, I'm tricking myself. Why would I trick myself? That's silly. I don't want to do that. So I'll erase that. I'm going to put back here 1 and 2. That means I can actually look at these, and I notice that 2 of these points and 2 of these points look the same. So now I'm moving over to 3/4, and I see that there was also 2 pieces, so I'm going to make it again the same. Now what my eyes are going to tell me is that, clearly I have the same amount of pieces that are 5/8 of an inch and the same as 3/4 of an inch long. So I know that if I'm, doing something with my information, I know what I have. Let's continue. 7/8. I have 3 pieces. So here's my 1, here's my 2, and here's my 3. I'm going to make sure that it's the same and the same part or same distance across or as up as this one. I'm sorry, as tall as this one. I just said up, that's funny. So that's the same thing here. I can still tell that I have more of these than I have of these. And then 1, I don't know. There is nothing there. So I guess if there's nothing here, I really shouldn't put anything here. I'm not going to make up any of my data. That's going to That's going to throw me off totally. Why would I do that? So nothing here means nothing here. 1 1/8. Oh, nope. Nothing here means nothing here. So we're at 1 1/4. Ah, there we go. And there's my 2. So I'm going to go, oops, where's my pencil? I'm going to go here to 1 and 2 pieces. So the difference here is that I can see I have good use of data here, but here I can actually see it. I can see that I have 2 pieces, 2 pieces, and 2 pieces of similar lengths. So it's nice for me, like if I was a crafter and I would need to know that, it's clear for me to see that. It's also very clear here to see that I have the most pieces that are a 1/2 inch long. In this case, sometimes I don't even need to know the number. I'm just can use this to figure out that I have more or less of something. Okay, so I placed the shortest pieces in a row end to end. How long was the row? So the shortest pieces, well, shortest pieces, I want to stop right now. I have a feeling that some of you might choose this, but that's the shortest or the smallest amount of pieces since there's none. The shortest, that means we're measuring this in inches, are these 1/2 inch pieces. Those are the shortest pieces. So she placed the shortest pieces in a row end to end. How long was the row? So let's see, I have 1/2 inch pieces and I have 4 of them. Well, there's 2 ways to do that. I can definitely use my skills of repeated addition, and I can add 1/2 plus 1/2 plus 1/2 plus 1/2. I know my denominators are the same, so I'm going to leave my denominator the same and add my numerators 1, 2, 3, 4. Ooh, improper fraction. You know I don't like improper fractions. They're like topsy-turvy, right? So how many 2s and 4? I know some of you just said 2. That's awesome. Whoever just said that, you're great. So now I have 2, but what am I missing? Oh, I also just heard someone say unit. That's awesome. All right, so what am I going to say? How long was the row? 2 what? Inches. You said it right. Good job, inches. What's another way I could do this? Someone yell it out right now. Yay, you did it. 1/2 times 4, because there's 4 of them there. So we're going to rewrite my whole number as 1/2 times 4 over 1. I'm going to multiply my numerators, multiply my denominators, up, and I end up with the same position I am here, which is going to give me a whole number of 2 inches. So if I place the shortest pieces in a row, end to end, how long was the row? The row would be 2 inches. You get that idea? Okay, if you have a question right now, what you should do right now is go into your Google Classroom and ask your teacher. So contact your teacher if you need any clarification, all right? On this one here, I want to quickly throw this one in here for you because I really want to talk about this difference part here. So again, look, I have a break in line because for sure, you know, if I have 2 1/4 here and 2 3/8 and 2 1/2, I just have this small amount of space as I'm showing my increments increase by a small space. This is definitely not from 0 to 2 1/4. 0 should be off the page at this point. So here I have this break in my line that shows me that this is actually longer than it's supposed to be. So let me go ahead and put my information in here. A group of students measured the widths of their hands. The measurements are shown in a table. The widths of their hands. So from pinky to finger. All right. Well, I don't know. I have a small hand, so if I had 2 hands right now, I would do it for you, but I'm holding the camera with one. Okay, 2 1/4 here. I have 1 student, so I had to find 2 1/4 inches. I have 1 student. I'm going to go ahead and use my X again because I like the X. 2 3/8. I have, 2 inches. 2 kids. 2 students. 2 1/2 is right here, and I have 2. So I'm going to go, look, I'm measuring that up, making sure that those are equal distance. 2 5/8, I have 4 of them. Let me be careful. 1, 2, 3, and 4. I'm all the way to the top of my graph now. 2 3/4, I have 2 pieces. And 2 7/8, I have 1. Look at that. It's like a nice little bell curve there. Okay. All right. So what is the difference between the width of the widest hand? So we're talking widest hand. That's a large number. And the most common hand width. Oh boy, I wish we were in class right now because I'm really interested in who would know. What's the most common? Oh, most common, I think that's like a mode or something. Anybody? Anyone? Right? Hey, if you know what mode is right now, can you go on, pause my video, and send me a message and tell me that you know what mode is? I'll give you an extra credit today. All right, what's the difference between the width of the widest hand? So the width of the widest hand here is 2 7/8, right? 2 7/8. The most common hand width is the one that we see most often. So we have 2 here, 2 5/8, right? We're finding difference. What is difference? That is subtraction. We got to find the difference between those two. We're going to close the gap, right? So if we're going to find difference and we're subtracting, we have 2 7/8 minus 2 5/8. Luckily, my subtraction works out nice since I have the same whole number and 7 is larger than 5, so no need to rewrite. I'm going to go ahead and say, well, my whole numbers are the same, so there's going to be no whole numbers, and 7 minus 5 is 2 with a denominator of 8. So what's the difference between the width? Well, that would be 2/8 of an inch. But we just learned how to simplify fractions. And I know that 2 and 8 are both divisible by 2. So I'm going to erase my unit here. There we go. I'm going to divide my numerator and my denominator by 2, because if I divide both of them by the same, I'm going to end up with a simpler fraction. 2 divided by 2 is 1. 8 divided by 2 is 4. 1/4. It can't go any further than that. I can't divide 1 by anything except itself, and that just makes it the same, and that's a waste of our time, right? So what do we end up with? 1/4 of what? Inches. Okay? Good job. All right, excellent. On the end, on number 11, we're going to leave number 11 here, but what I would like you to do, let's see, should we write a problem using our line plot? I would love for you to do that. Why don't you go ahead and let's make this an extra credit as well. Extra credit here, opportunity. Yep. So when I grade 249, if you're getting me the extra credit, oh yeah, and you told me what mode is, I might actually add a little bit extra there, okay? See if you can write another question like this one using this data. I would love to see how you're using your brains, okay? So now that you have this page done, you're going to turn your page to this one, and you're going to go through this one and complete these questions on your own. This is where we define a line plot. Line plot is a graph that shows data using a number line, okay? Mateo wants to bake raisin bread. He has several recipes that can make each one loaf of bread. The line plot shows the number of cups of sugar. Numbers of cups of sugar, okay, in the recipes. So cups of sugar. I feel like that word cups is really important. I feel like I should be paying attention to it. So, how many recipes does he have? Think about your line plot. Think about your plots. How many recipes? Not how many cups, how many recipes? So, we're looking at recipes there. How many of them have more than a half a cup? So, think about more than a half a cup. Use your data. What is the least amount of sugar in any recipe? So least amount of sugar. So we're looking for those cups there. How much less sugar is in a recipe with the least sugar than in a recipe with the most sugar? So think about a recipe with the least amount of sugar compared to a recipe with the most amount of sugar. So we're looking for a difference here. So think about that as you're solving these. Mateo wants to try all recipes with exactly 5/8 of a cup of sugar. How much does he need? I feel like we can do that and make a combination. We're going to combine here. And then how much sugar would you expect any recipe for raisin bread to need? Explain your thinking. That means use this data now. So when we create data plots, we have to use it. We got to make sense of it. There's got to be decisions that we can make. So when you think that we're making a recipe for raisin bread to in your own home, what do you think would be a good amount here? Okay, what would you expect any recipe for raisin bread to need? What do you think? So make a decision. There is no right or wrong answer. This is an opinion question. So when you say whatever you think it is, you got to explain it using that data. Okay? All right. Send your teacher a message or a question if you have it. And when you are finished with this, there are 2 options that you can do. There's a Google form. You could take a picture of it with your Chromebook and then it will go to your downloads folder, and then you can upload it to the Google form, or each one of these questions is in Google Forms. You can just go ahead and answer them on that form and turn it in. Either way is okay. All right. Again, message your teacher with questions. We'll talk to you soon. Bye.